Hello, this is John Baugh again, and this is session 8. Today I'm going to go over some of the topics which are in chapter 9. You'll notice by our syllabus, if we look at our syllabus here, this lecture being for the week of July 1st is on Classes: A Deeper Look Part 1. This is on Chapter 9, and next week is also on Chapter 9. So your Project 2 is due the end of the week of the 8th. So if we look at that, the end of that is on Friday, so that's the 12th at 11:59 p.m. So you've only got, about, a week and a few days to do it. So make sure that you don't slack, and if you need help ahead of time, please contact me, and we'll try to work out something to make sure you understand the subject matter better. The Program 1 and your midterm grades are posted. If you, for some reason, missed the point of the program, or you've missed the midterm entirely, I think there may be a couple people who are registered for the class who never really did anything as far as the midterm and or the project are concerned, so I'm not sure if they've dropped or if they're just kind of not paying attention to what's going on. But if you got a really low grade on the program and you'd like to make up the points, perhaps and redo it, I will restore some of the points if you're willing to redo it. Some of you might have to come in and actually see me, or at least email me and make contact to say, hey, I apparently didn't understand the first program. I thought I did, or I didn't understand it at all, and I didn't know how to get anything set up, or whatever you want. You're going to have to just contact me and we'll figure out something. By this point, obviously you should have some sort of working compiler or IDE, integrated development environment, like Visual Studio 2012 or 2010, or if you're on a Mac, maybe Xcode, code blocks on Linux or what have you. But you do need to have a working IDE and compiler by now. If you don't, you are definitely behind. So you need to contact me if you're having significant trouble still. But I think by this point everyone's got something going. Worst case scenario, you'll have to come to one of the campuses, and all of the campuses that have CIS departments have labs that should have some open time for you to work on them. There's Auburn Hills, there's one in Waterford, which is the Highland Lakes campus. There's the obviously the Farmington Hills campus, which I'm located at Royal Oak, Southfield. So I mean, you've got ample options to what you can do. Also, if you're from another university or college, you're maybe auditing this class or taking it separately or just taking it for credit, so you don't have to pay university prices or whatever the case may be. It wasn't offered at a time you could do it at your home campus, your home university. Then your home campus or university probably also has some sort of compiler IDE set up in their computer labs as well. So you've got multiple options. I would recommend taking advantage of them as much as possible. So, okay, so today I'm going to do something maybe slightly different, but not too different. I'm going to actually go over the course notes, since this covers pretty much all I want to get in this week. The first section of the course notes, it says it's an introduction to, it's session 8, it's an introduction in the first part of chapter 9. So you know what? I don't think I changed that title. That's kind of silly. Alright, so you could ignore the title here. That's actually not accurate. This is actually on Classes: A Deeper Look. I'll probably change that later. So, alright. So anyway, this section is the include guards, const member function, and member initialization lists. To prevent a header from being included by the compiler more than once, we use what are called include guards. They define a so-called macro variable, and then every time another file tries to include the header file, the macro variable's existence is checked, meaning did we define that variable or not. If it doesn't exist, include the file. If it does already exist, that means the class header file was already included, so don't include this file again. We'll get to all of this in just a moment here. Another topic to enforce good software engineering principles, specifically what we call the principle of least privilege. We kind of talked about that before when we were talking about const correctness last session. We can also use the const keyword in the context of class member functions. So, and thirdly, we can use what's called a member initialization list, which is another way that allows us to initialize data members without using assignment statements in our class definition. It also is an appropriate way to initialize constants in C++. So the rule of thumb with this is that if a member function should not modify, this is for the const data, I think this should probably be up there, but a rule of thumb is that if a member function should not modify an internal data member, then declare that member function with the keyword const after the closing parenthesis of the member function. So let's consider a simple class representing a circle. So I've already got Visual Studio fired up and the project created, but there's no files yet. What I'm going to do is I'm going to create a main file that will use it, use the class we're going to create. But this will just be the skeleton driver program. Okay, so this is our skeleton driver program. Now, we'll come back to him in just a second. First things first, we're going to make a header, and we're going to call it circle.h. So I select header file, and I call it circle.h. Alright. Now, we're going to create a class pretty typically like we've done before, but there's a little bit of a difference. We're going to use a difference. We're going to use something called include guards. So I'm going to set up the include guards first, and then we'll come back and actually write the class. So if in def circle underscore h, define circle underscore h, and then we're going to have an indef down here. Now, what this is you'll notice there are pound signs in front of these. Where else have we seen pound signs? Right? You've seen it in front of the include statements in the main file and other files we've used before. Include iostream, include string, include circle.h, which we'll need in just a second, so I might as well do it. Circle.h, right? Include statements have a pound sign. Now what that means with an include statement is the preprocessor, which is part of the compiling environment, before the compilation is actually performed, the preprocessor goes through and looks for preprocessor directives. Okay, this is a preprocessor directive, hash include. That's what the hash symbol does. Okay, pound sign, hash symbol, number sign, whatever you prefer. So the preprocessor looks at this and says include iostream. So what it does is it includes that entire library contents, and then when it sees include circle.h, it includes that entire header contents and its descriptors, and then you can actually use that stuff in main. It's as if you defined all of this stuff inside of this file. Even though we're keeping our file nice and clean, and we see this when the compiler, before the compiler actually gets to compilation, it has all of the appropriate stuff included in here. Okay, so the preprocessor acts before the compiler actually does the compilation. Now in circle.h, when we have if in def, what that means is if not defined. Okay, it's like an if statement, kind of, but this is used by the preprocessor. It's not actually C++ code per se. Okay, it's part of the upper level compilation code. So the preprocessor directive says, if not defined, we're going to define circle.h. So if it looks for a variable named circle.h. Now this is what we could call a macro variable, okay, macro level variable, circle underscore h. Now I could call this sausage or horse or whatever, but it's customary to write the name of the class underscore h, because it's a header file. It's the name of the class in all caps underscore h. That is just customary. Again, it's not required, but pretty much every time I've ever seen this, it's done this way. So it says if it's not defined, then you go inside of here. This is sort of, I'm just going to write this right here just so you can see, but it's not going to be appropriate because it's not, you know, actual code right here. But we'll say if circle h, this is kind of like, or if circle h not defined, okay, if not circle h, then we're going to do something. Otherwise, if this is false, or if this is false, meaning if circle h is defined, you skip it, right? You skip it. So that's pretty much, it's kind of analogous to an if statement in C++. All right. So if it's not defined in def, now there's also an if def, but if in def means not defined. If circle h is not defined, we do define it. So that means the next time this is ever read, if we ever test, if the macro, the preprocessor tests if this is defined, once we've done it this time, this will be defined now, this circle h. So wherever we look at it from within the program, this circle h is defined now. Okay, so now we create our class outline here, class circle. And remember, in C++, now a lot of you had a problem with this, so I'm going to try to clarify this a little bit. The semicolon at the end of a curly brace, you're not going to see this very frequently. It's going to happen with classes. You do not do it with functions. Look at main right here. There's no curly brace, or there's no semicolon at the end of the curly brace right here. Everyone see that? There's no semicolon at the end of the curly brace. It only happens at the end of the class definition, or declaration right here, the specification. Now, inside of here, we're going to have the constructor, and then we have a few other methods we want to introduce. We have we probably should have the public and private part, right? Public and private data. Okay. For the private data, we'll put that in first. We're going to have a double radius and const double pi. So double radius and const double pi. And some of you might freak out right now and say, well, why aren't you initializing this because it's a constant? Well, this gets a little bit furry right now because some of you might be using different compilers. In Visual Studio 2012, which supports the new C++ standard, I could, if I wanted to, initialize the pi here, the const double pi here, if I wanted to. This is perfectly legal syntax in the new C++ standard, which is called C++ 11 standard. The old standard, the older standard, most recent old standard is C++ 2003. Okay, but it is not backwards compatible, because if you're using an older version of Visual Studio, or if you're using another compiler that doesn't support the 11 standard, then this will actually be a compiler error. So that's not good. But I will show you a way that it's compatible in all the modern compilers. Okay, so that is a const. It will be a const, but we need to initialize it, but I'll show you how to do it, which doesn't break any of the rules. Okay, so we also have set radius, void set radius. So this one's pretty self-explanatory. It's going to take a double R. And then we have get radius, get area, and get circumference, all double. So get radius, and I'll explain this in just a second, get area, and get circumference. Now, you'll notice something different I'm doing now. I'm putting the word keyword const, which we've seen before, after the name of the member function. Okay, after you have the data type, return type, the name of the member function, and then you have the keyword const after that. Well, why isn't it after this one, set radius, and why isn't it there? Or why is it here? Well, set radius modifies the internal data member. It will modify the internal data member radius. Get radius will not. Get radius just returns whatever the radius is. Get area, we perform a calculation using pi and the radius, and same thing with circumference. We perform a calculation and return it. We do not modify or change either of these. Okay? If you needed to change the radius, which we do here, you cannot declare that member as const. Well, what does that do for us? Well, if you do everything right, you're not going to notice much of a difference. But if you, let's say you're coding along and you accidentally forget that you don't want to change this, you don't want to have this method modify any of the internal data members, if you forget that and you do try to modify an internal data member inside of one of these methods labeled as const, then you will get a compiler error. Okay? And you might think, well, aren't compiler errors bad? Not always. They're your friend. Okay? Compiler errors can be your friend too. So if I accidentally modify something, I can look back and say, oh crap, I didn't mean to do that. So then you work out an alternative way to do what you were trying to do. Or you do have the option, let's say later on we decided that one of these had to modify an internal data member. Let's say we wanted to add a private data member called area, and every time we call get area, it updates the area and returns it. So you want to do two things. Then we would have to remove const. Okay, because that is now modifying an internal data member. But this is all we need right now. We do need a circle.cpp now to do the implementation. Okay, so it's a CPP file, circle.cpp. And I'm going to include circle.h. Okay, so I explain what the include guard does a little bit more thoroughly here, and it's in black and white here if you need to read it a couple times so you understand what it's doing. But basically, every time let's say I have multiple files in this project and I need to access circle, I can include circle at the top of each of those files just to ensure that it gets included. But in the whole grand scheme of things, let's say that I have a file called sphere that includes circle, and then main includes circle and includes sphere, okay, another class, then what am I really doing? If I'm including sphere's header file, which in turn includes circle's header file, and I'm also including circle.h also, then you're going to end up with this thing where you end up with two inclusions of circle.h inside of main. So to prevent that, that's why we're using the include guards here. Okay, so and this is kind of like the closing curly brace. This indif down here is like the closing curly brace of an if statement. So the second time it goes through here, it'll say if not defined. Since circle_h will be defined, we will skip all of this inside of here. The preprocessor will not re-include it. So this is very, very useful. It's also very good programming practice. Okay, so the next thing we're going to do is we're going to create the circle.cpp. The first thing I want to do is I want to define the constructor. All right. Now, we're going to have a little bit of an issue here, because if you hover over this little curly brace here, notice that it says error provides no initialization for const member circle pi. That's because pi is a constant and has to be initialized. Now, if I try it this way, what's it going to tell me? It's going to say expression must be a modifiable L value. Consts cannot be on the left-hand side of an assignment operation, right? So how do we solve this problem? Well, there's a little trick we can use called an initialization list, or a member initialization list. You put 1: after the name of the constructor, and I'm gonna actually do it on both of these variables, because you can do it to non-constants also, like radius right here. Radius is a regular variable. I can do it to radius. I can also do it to pi. And you use kind of a funny syntax. I'm going to set pi in using like a functional syntax, comma, radius, I'm going to set to 0. Okay? That is called the initialization list. Now, this is guaranteed to occur only once when the object is created. That's why the compiler allows us to initialize a constant here. It says it's the same thing as if we were to do it here, except it's allowed in older versions of C++. Whereas in the newest version of the C++ standard, like I mentioned earlier, you could initialize it here. But this is backwards compatible for all the versions of C++. Okay? So initialization list. Some people prefer using this syntax rather than, because I could take radius off of here and do this. If I wanted to, I could say radius equals 0 here. Because radius isn't a constant, we can initialize its value inside of the constructor here. But I just chose to use this member initialization list syntax to do it. Okay, so the next thing we're going to do is we're going to define the set radius method right here. Okay, so void, and then we have to have the name of the class. Remember what these two colons are called together, the scope resolution operator, right? Okay, so we want set radius, and then what it has inside of the parentheses is a double R. Okay, right, and then I'm going to set the internal data member radius to R. All right, that's pretty easy. Notice again, there's no const after it because we are modifying an internal data member radius to set it to something else. It doesn't matter if I'm setting it to 5 or 10 or 12 manually, or if I'm setting it to a parameter or some sort of calculation. It doesn't matter. If you're modifying it, if you're ever using the radius as what they refer to as a modifiable L value, if you're modifying it as an L value, you must not have const after this. Now, here's another question I received from students. What if, because they've seen a lot of this, where the name radius here is sometimes used as the parameter name. But here's our problem. It's also used as our private data member name. So which one, if I refer to radius in here, let's say I say radius equals radius, that doesn't really make much sense. The reason it doesn't make much sense is because inside of this method, if I just say radius, this scope overrides the scope of the private data member. So this local variable has higher precedence. So this is basically, you're just setting this local, it declares a local variable, reserves memory for it, sets it to itself, and then goes away. It never modifies the internal data member radius here. Well, how do we get it to do that? Well, there's the special keyword that we talked about once before, and I believe I've mentioned this in passing, but if you do have the same named parameter as you do an internal data member, you can do this. Okay, so I can use this, and then I use the arrow operator, and then the word radius. So now this one right here is referring to our internal radius, private data member, and then this one is referring to the parameter that was passed in. All right, pretty cool. Now in a language like Java, you will see the dot operator here, because this you don't have the arrow operator in Java, and with Java it automatically does conversions between things that are essentially pointers and things that are not, but we won't worry about that. To keep for simplicity's sake, though, I'm going to use different names. Radius equals R. Okay, that's okay to do that. And again, this one does not have to even match this right here. All right, these actually don't need to have anything in them, really, if there's a parameter. I just need to state this has a double. That's all I need. But this one does have to match. This has to be the same name as this, or this arrow radius if you want to. Okay, or if you need to in some cases, like I just described. So the next thing, the problem here also, you might notice there, what do we do if the person enters a negative number? Well, that's not a valid radius, is it? Okay, so what I want to do is I want to say if the radius they enter is greater than or equal to 0, right, set radius to R. Otherwise, if they enter negative 500, I'm going to set the radius to 0. It's not a good radius, but at least it's not a negative radius, because that will give what appears to be a valid answer, and it's not. Okay, so that's what we do. We do have one specific thing we need to go through when we do that. So I would recommend that you always go through and try to determine what do I need to check. What do I need to check when I'm going through? and setting any of my internal data members. Do I need to check if it's outside of a particular range? Okay, that's what we do with that one when we're modifying internal members. So this is a good function. The next thing we're going to do is we're going to get the we can look over here if we want to. I'm just going to drag that over there. Notice you can move the tabs across the top. I'm sure probably most of you figured that out, but if you didn't, I can move this one there, that one there. It doesn't really matter. You just click and drag it. But we got get radius, get area, and get circumference. I'm just going to copy all these, and I'm going to put them here and set them up properly. Okay. And just okay. Now the other thing that you need, remember, is you need to put the scope resolution operator in the name of the class. Otherwise it'll get confused and have no idea what the const is for, and it'll be really bad. Because in the context of functions, you can't have a regular function that does not exist inside of a class with the keyword const after it. It doesn't make sense. Because remember, the meaning of const is I don't want to modify an internal data member. If you're a function that lives outside of a class, that doesn't make any sense, does it? Right? Because you don't have any internal data members you're associated with. Okay, so get radius, pretty straightforward. Return radius. The function for area of a circle is what? Pi r squared. Pi times r squared. In terms of what we need, we can do this. We can say returns pi, which is our internal data member, times radius times radius. Now, you could include the math library and use the power function, but personally I think since it's only squared, this is just as easy. This is really not complicated. This is our r squared here, and then this is our pi, right? And circumference, what is circumference? Circumference is 2 times pi r, or 2 pi d, right? 2 times pi times d. So we're going to return 2 times pi times r. Radius, sorry. I forgot that wasn't the name of our internal data member. You have to keep consistent. Even if I named this sausage, it doesn't matter what the math formula says. It has to match what my internal data member is. So that's pretty much what we have there. The next thing I want to cover is using pointers and the new keyword with classes. So previously we have declared objects of classes, and we've declared them on the stack. Okay, this is called on the stack. So if I do this, if I have a circle here, and I say circle, I'm just going to call it circ, and then I say circ dot set radius to 10, and then I say cout circ has area circ dot get area. Okay, notice something here. When I'm making a call to a function, even if it has no parameters, do not forget the open and close parentheses. I saw a few people left them out in their projects, and it printed out like some gobbledygook, which is basically just a memory address. That's not good. Okay, so make sure you're actually calling the function. If you don't, it's going to go into memory and say, where is the memory address of that function? That's all it's doing. Circ has circumference, circ dot get circumference. All right, so let's build and run this, and we'll see if it works. All right. Takes a while the first time, especially. Build succeeded. Okay, we're going to run it, and you notice it says the circle has area 314.159 and has circumference of this, right? 62.8318, right? Okay, that's exactly what we expect. But when you declare this circle right here, this is not like a language like Java. There's a lot of subtle differences between this and a language like Java or C#. In C++, it declares a circle, okay, an object. If you just declare it like this, it declares it on what we call the data stack. Okay, the data stack's the same area of memory that memory is reserved for things like integers and floats and doubles, etc. Okay, those are what we call value types, not reference types. So in some languages, There's a distinction automatically made by the compiler, but not so in C++. If we want to declare something on what's an area of memory called the heap, okay, or the free store, we have to use a pointer. So I'm going to say circle pointer ptrc equals new circle. Okay, well, what did this do for us? Well, the new keyword is an operator, just like multiplication or addition. This is just a special operator, and what it does is it causes there to be memory reserved on the heap, which is another area of memory. It's not the same area as the stack. It's a different area of memory. The heap is a special area of memory where you can dynamically allocate memory at runtime rather than at compile time. Okay. As you're going along, you might need to dynamically, even in a for loop, I could have maybe an array of these circle pointers, and I could dynamically add new pointers. I can't really do too much of that without knowing exactly what's going on ahead of time. I can't really do anything with the regular old stack-based memory reserved. Okay, and this is heap-based, right? Heap or free store. So what new does is it reserves that memory from the heap and then returns a pointer to that area of the heap. So now what do? Well, there's a shortcut syntax that I showed you earlier, ptrc, and then I use the arrow operator. I have to use the arrow operator because what the arrow operator does is, if you'll remember from last session, we did something called dereferencing. That's where you ask the pointer, what do you point to? So the arrow operator first dereferences the pointer. It says, I want to know exactly, I want to talk to the circle that's directly on the heap. And then when you use the area, it says, okay, well, I dereference it first, and now I've got access to all of these methods. So I'm going to set radius to, let's say, 12 in this case. And now later on, I'm going to put a little extra space in between these two. And I'm going to say ptrc's circle has area ptrc. And notice I'm using the arrow operator because this is a pointer. And ptrc's circle has circumference. ptrc get circumference. Right? Okay, so let's build and run it and see if it gives us what we expect. And it does. Pretty much does. So 12, you've got 12 squared, which is 144 times 3.14159 is 452,389. And then you've got the circumference, which is calculated to 75.382. Well, both of them do essentially the same calculation, so you might think to yourself, well, why is there any benefit in using heap-based memory? Well, there's some that we haven't really covered and we won't get to deeply in this course. If you take a Computer Science 2 course, a more advanced course on computer science and C++, you will learn a little bit more about making use of dynamic memory. So you might create data structures called linked lists, or the queue linked structure, the stack linked structure. There's different data structures that we deal with in computer science, and that requires you to dynamically create memory at runtime. That's one advantage. Okay, so if I do not know how many of these circles I need ahead of time, then it's prudent that you use the new keyword. You could make some gigantic array, static array on the stack, but that's a waste of memory. All right. There's another thing you have to do when you use a new keyword, is at the very end, when you're done using it, you want to delete that memory. Now, what delete does is it does not destroy this variable. I could later on reuse this variable. It does not destroy the variable. Okay. What it does is it returns this memory to the heap. Now, in this case, it's not a huge deal because immediately after we delete it, then we return 0. The operating system will eventually reclaim this memory and everything will be hunky-dory. But a lot of times while a program is running, we're calling new a whole lot of times. In games and graphics programs and just any program that's using a lot of memory, a lot of them are using dynamic memory. So if they're not deleting, okay, this is kind of in Java. There's a concept of dispose, or disposing of the memory that you're not using anymore. So that returns it to the heap. This is what delete does too. But in C++, it's required. With Java, you could have something similar to this, although they don't use pointers in Java. You could have something with the new keyword, and then later on, Java will automatically remove it for you because it has automatic garbage collection, is what it's called. We don't have that luxury in C++. We have to do it manually. So every time you create one, get used to deleting it when you're done. Okay. Another interesting advantage to using heap-based memory is that I can automatically just use this pointer and pass it around to functions with relatively little problems. So it doesn't really matter how big this circle class is. You'll remember when we did pointers last session, when I talked about passing them as by reference or by reference by pointer to a function, it only passes the pointer, not the whole object. So basically, you're giving it an address and saying this is where this object lives, rather than trying to push the entire object onto the function's call stack or data stack, and then you end up with all this data that has to be transferred back and forth. So if you're calling a function, 100 or 1,000 or several thousand times, in a row, you're going to make a whole lot of savings if you pass a pointer to the object rather than the object itself, especially if it's a big object. What if this circle had 120 data members, or 50 data members, or even 20 data members? If you're passing this whole circle to the function over and over and over and over and over again, you're going to notice that the memory that's taken up will be larger, and it will also slow down, because the functions have to take the time to push all that data for each object onto the stack, their own personal stack. Whereas with the heap-based memory, you're just passing a pointer. A pointer is basically the size of an integer. It is an integer ultimately, because remember when we printed out pointers, it has a memory address. So if I say memory address on heap, and I say ptrc, just like that, it should allow us to see the memory address. Yep, right there. There's our memory address on the heap, where this thing lives. Okay. Now, it does not mean that this will be the same number each time. In fact, this is different this time, which is fine. When the delete is called, you also call something called the Disruptor, which we didn't really cover in here. But to make a Disruptor, you just put tilde sign and the name of the constructor, essentially, and then you define the Disruptor here. This is also important in some structures that you might deal with in the future. For right now, it's not really going to... oops, I should have the tilde on it. Okay, for right now, it's not really going to do anything. I could print out something just to prove when it's calling it, but they do that in the book, so I'm not going to really bother with that. See if everything else is good here. Yep, I give you an example of how to use it in main. The arrow operator. One other note I'd like to make is that this arrow operator is actually shorthand for something that you could do manually if you wanted to. You can dereference the pointer first. Remember the dereference operator? If I put the star in front of it in this context, and once I dereference a pointer, then I can use it as if it's the original item. So since I now have the original circle that lives on the heap, I can now say dot. So if I want to set radius this way, these two are equivalent. Okay, these two right here are equivalent. You have pointer C set radius, or you dereference the pointer first and then say dot set radius. It's preferred to use the arrow operator in C++, just because it's shorter, it's a little more clear as what it's doing, and you automatically know that this is a pointer, okay, when I look at it. Also, it's handy, although not required, to put PTR in front of the names of pointers. All right, so that's something else you might want to keep in consideration. Now, what happens if you do have a bunch of these items being declared with new and you don't delete them? Well, throughout the life of your program, the program just keeps getting larger and larger, but these objects, for example, if I declare one in a function and I never delete it, let's say I have another function that declares something and never deletes the item, then it's going to keep creating stuff in memory, and if our program's still running, and the program will keep getting larger and larger and larger, and none of that memory that we're not using anymore gets returned to the heap for our program and other programs to reuse. So this state is what we call a memory leak. A memory leak. It sounds like a leaky bucket. It basically just means that the memory is no longer pointed to. We have no way of accessing it again until the program closes and resets. There are very big programs. In fact, Microsoft Internet Explorer, and it's a little better now, but a lot of programs, even Firefox I've noticed before they made some updates, so we can't just completely pick on Microsoft all the time. It doesn't mean they're incompetent programmers. It just means that sometimes you might miss one little tiny memory leak, and you'll have to go back and they have to release a patch and Windows Update and all this other stuff. This happens in video games constantly. Don't think that World of Warcraft has never had a memory leak before. This happens frequently, but you as the programmer want to reduce the number of memory leaks and ideally remove all of them from any software that you release. Sometimes they're very difficult to find, so it's just a good idea to get, because it's not a compiler error. It's not going to flag this, oh, you didn't release this memory. Since this all happens dynamically at runtime, we don't know. The compiler has no way of knowing if we release the memory. That's not a compiler issue, it's a runtime issue. But it's not a runtime error per se. It's what we call a logic error, or a poor memory management is what we call. So if you ever hear the term memory management, which you will if you stay in programming anytime, for any time, memory management means you're having your program return memory that it's not using anymore, reserve memory only when it needs it, etc. Okay. All right, so that's pretty much it. I'm going to quickly go to the discussion board if it's anything that's pertinent to our class. Then if it's something personal or something, I'm not going to bother reading it. Idea of the constructor. The book gives a definition, not to my satisfaction, to when to use a constructor, when to apply a constructor, and its function. The concept seems foggy to me, but I know it's not that complex. Okay, constructor is whether you're doing this or you're doing this. When you have a constructor, there's always a constructor, even if you don't define one in here. If I left these out, there's always a constructor. That's called automatically. It's created automatically by the compiler and actually inserted into this file if you don't do it yourself. But a constructor is called automatically whenever you define or declare a variable. So when I do this, it calls the constructor automatically. So whatever we do in here, in this case, all we're doing is we're setting pi to 3.14159, and we're setting the radius to 0 in this initialization list. Or anything you do inside of the body here is guaranteed to be done before the user calls any of these other functions. Okay, so if you have any kind of memory to reserve, if you have another object you need to initialize in there, you can do that. Anything you need to do before your object is utilized, you have to have it in the constructor. Okay, so that's an object-oriented idea. Since Fortran doesn't really rely on object-oriented concepts so much, that would make sense why that wouldn't really jive with how things work. But think of it as an object-oriented concept, that the constructor is called immediately after you declare a data type. If it's stack-based, immediately after you declare it, or if you're using a pointer, remember this is not a circle here, this is a pointer to a circle. This is where you actually get the actual circle is created on the heap. So as soon as this is called, this new circle here, as soon as that is called, the constructor is called automatically. in fact, the syntax actually kind of looks like you're calling the constructor, right? Because, you know, you kind of are. Right? So you got this right here, circle with no parameters and circle with no parameters, right? Okay, so it's just one of those things where you just keep in mind that if you have any kind of housekeeping or any kind of thing to do before your object is actually used, before we want to set radius, one example of why we might want to do this, when the constructor is called, it sets pi to 3.14159, which we need for our calculations, and it sets radius to 0. So if we did not have an explicit constructor defined here, and let's say we skipped the set radius here, the rest of these might not have good data or valuable data with them, but they won't crash the program. If you try to perform a calculation on memory that you never reserved properly, these could actually crash the program if you did not give them any kind of data, or you're trying to perform a calculation with garbage data. It doesn't make sense. There could be anything at those memory locations. So in that context, it's important to have the constructor so that it causes there to be whatever kind of initialization needs done before you actually use say for example the get area. So if I call get area without these, it's at least not going to crash. Okay, it might return 0, but we have at least something set for the original value of the radius and pi. Okay. Also, the constructor is useful for the thing we covered today, initializing constants. The destructor is called automatically before the it's either automatically, well, actually it's called when you type the word delete. In some languages it's called automatically, but when you call it with delete ptrc, just like new reserves the memory, delete calls a constructor, or if it's a stack-based memory, the destructor is called when you go out of function scope. Okay, so a couple different instances, but just think of it as something that's very valuable as far as the management is concerned. So if you guys have any questions, we're still in chapter 9 next week, because I wanted to make sure everyone got, and by next week I mean the week after the 1st. I'm a week ahead here. So by the week of the 8th, I wanted to make sure people didn't have an extremely stressful July 4th weekend. July the 8th, the week of July the 8th, we'll be covering the rest of chapter 9, and I appreciate all of you listening in. I hope that you're all listening to the lectures, and if you're not, if you have any friends that are taking the class, please encourage them to do so. I believe the people that are listening to the lecture are probably doing better on their assignments and also on their homework, and they did better on their midterm because they're paying attention, they're going back to good resources. I hope this is useful. So if anyone needs clarification on anything, please contact me, and I'll see you next week. Thanks, and have a great week.